The OSPF network type setting can either help or hurt. In this lab, you'll get a chance to experiment with the two primary types, broadcast and point-to-point. Each of the config labs has a blog page at my blog. So at that page, there'll be a scenario and tasks listed at the top of the page. Then a suggestion to go do the lab, and you can do it in Cisco Packet Tracer. Then the bottom of the page gives the answer and explanation to the lab. To make that a richer experience, I've made an intro video that goes a little deeper on the intro section and a review video that goes a little deeper on the review. This video is the intro video for a lab. So what lab is that? It's a lab about the OSPF network type. You can find the related topics in the official Cert Guides, Volume 1, Chapter 23, Section 1, by the way. And there's a direct link to the lab. If you don't already have the page open, there should be a card up above my head here for you to click as well. So you should open that page now, jump in, and read the lab. That blog page shows the initial state, but I'm going to walk you through it in a little more detail. So we've got a topology with 4 routers. We've got these 3 WAN links in the middle between R1 and R2, R3, and R4, respectively. In the big blue letters here, I've got the subnets used in each case. There's also over here on the right, R2 and R3 are connected to the same LAN subnet over on the right. So that's the topology. We've got the subnets listed, and there's some meaningful initial configuration as well. Basically, OSPF is enabled on all interfaces, placing all interfaces in backbone area 0 to start the lab. So just to show that configuration to support that claim, here we go on router R1. We've got these IP OSPF1 area 0 commands. And this is interface configuration for OSPF that basically enables process 1 and places the interface in area 0. So this puts interface gig 00 in area 0. This command puts gig 000 in area 0. And continuing in R1's config, this command places the next interface in area 0 and the next one. And finally, here's the OSPF process, and I pre-configured meaningful router IDs like 1111 in all 4 of the routers. Routers R2, R3, and R4 have very similar configuration, just fewer interfaces. Here on R2, it's got these 2 interfaces, and it's got the IP OSPF1 area 0 subcommand under both of those, referring to process ID 1 on router R2, and it's got a router ID of 2222. Similarly, on router R3, it's got a router ID of 3333 with this same subcommand on its 2 interfaces, enabling OSPF in area 0, and of course, router R4, same thing. IP OSPF1 area 0 on both of its interfaces with router ID 4444 here on router R4. So with all that configuration, assuming all the interfaces are up, and they will be in Packet Tracer if you're using the downloadable file for lab, focusing on the bottom left set of comments, if you were to get into any of the 4 routers and ping any of the interface IP addresses on the other routers, it should work. Self-ping should work of a router's own IP addresses. Ping of the other router IP addresses should work. Also, any commands that display OSPF neighbor information should list the correct neighbors, and they're easily identified based on the obvious router IDs of 1111 and 2222 and so on. So there's your initial state. So what should you do? Well, your first job is to open up the Packet Tracer file and do some show commands actually. So think about things, think about this topology and think which routers should become OSPF neighbors, and then do some show commands and check out are they or not. So make sure of the neighbor state and think about how many of these routers, based on the default settings, particularly the default setting for the network type, is how many should reach a full state, and do they? Then think about which subnets should there be both a DR and BDR elected. And you can do show commands and confirm that. And we'll do that in the review video, by the way. So I want you to think about that. Don't just skip by this step. Then at step 2, I want you to do some configuring and then do some more show commands. So what we want to do is the typical case where when you've only got 2 routers on the link, like on these 3 WAN links, we want to change from the default of broadcast network type to point, and that's the job. Change the both ends of each of those 3 links to use point-to-point network type. The LANs, that is the outer interfaces in the drawing, leave them as network type broadcast. And then think about those same questions. In particular, how many neighbors do you have? Which ones reach a full state? How many type 2 LSAs do you end up with? And all those questions we just saw. You'll see those repeated in the blog post, of course. All right, so it's time to do the lab. There's the link to the lab at the top if you haven't already opened up the page. If you open up the page, you'll find a button where you can download the packet tracer file. And when you're ready, after you've done the lab, you can even check out the review video to see more. Thanks for watching the video. As always, YouTube things help. Like, comment, give the video a share. Do the lab. Let me know what you think of it. And if you're new, of course, subscribe and click the bell to watch for new videos. Thanks for hanging out. I'll talk to you soon.